This is part 2 of the chapter 4 introduction. This section will talk about fasteners and details about fasteners. The most common types of fasteners have spirals, threads, which we'll use to wedge parts together and keep them from loosening. Most fasteners are specified by size, which we'll see in a minute, and they must be replaced with the exact same size of part and also other specifications. Screws are the most common types of threaded fastener. It fits typically into a threaded hole, different designs for different attaching needs. Some require a wrench to install, others can be installed with screwdrivers or other types of driving devices. They're often classified by the shape of the head. These are some examples: a hex head cap screw, a flathead metal screw, a roundhead metal screw, a panhead metal screw. These are often referred to as self-tapping screws. They can be used sometimes in sheet metal or wood. We also have other machine screws which can be used for a variety of different applications, again, to hold two parts together. Typically, bolts use a nut to hold automotive parts together. They fit through parts that do not have threads. Most have a six-sided or hex-shaped head. Studs frequently are used in automotive applications. This is a fastener that has no head but threads on both ends and threads into one threaded hole on one end and has a nut threaded on to hold the part on the other end. Nuts are used with bolts and studs, have many different designs and different configurations, and can be specialized to specific applications. This is a typical example of a stud and a nut as far as a threaded fastener. Oftentimes we use a different type of washer for different purposes. A flat washer is used to prevent damage to the surface from the head of the bolt turning or the body of the nut turning on a part. Spring locks are often referred to as lock washers. These are a spring lock washer that are designed to dig into the two metal components as they're tightened down together to keep them from coming loose. Tooth locks washers can be internal or external, and again, they are metal-edged parts that dig into the two components to keep them from loosening. Threaded fasteners we will refer to typically in two ways, either as an SAE, English thread, or as a metric. First one we'll talk about is the SAE, or Unified USC system. Threads can be coarse, fine, or extra fine sometimes, depending on the application, and it's determined by the threads per inch. When we talk about SAE or USCS bolts, the size of the bolt is referred to in three different ways. The length is the bolt length from the bottom of the head to the end of the bolt. The shank or bolt diameter is the diameter of the bolt across the cross-section, as illustrated in the figure below. And what we need to pay particular attention to are the threads per inch. Threads per inch are the number of threads, number of peaks, measured in 1 inch. The illustration here shows a 16 thread pitch. So a 3/8 by 16 by 1.5 length would designate exactly what bolt we're using. I emphasize the threads per inch because that becomes even more of a factor when we talk about metric bolts. Metric fasteners can also be coarse, fine, or extra fine, depending on the distance between the threads, which are measured in millimeters. A metric bolt is similar to a USCS bolt, but there are at least one major difference. Typically, the bolt shank diameter is measured in millimeters. The bolt length is also measured in millimeters. But the biggest difference in metric bolts is we measure the pitch by the distance between two peaks. As illustrated here, this is a 1.75 millimeter pitch. So that means that from pitch to pitch is 1.75 millimeters. So this is actually an M12, which would be the diameter, by a 1.75 pitch by 70 millimeters long. So that would be the description of this metric bolt. Keep in mind, there are many SAE, USCS bolts and metric bolts that are very similar in size and will actually thread into holes. So if you're not careful, you may start an SAE USCS bolt into a metric hole or a metric bolt into USCS SAE hole. Never force a bolt if it starts the first few turns and gets tight. Don't force it. You may have inserted the wrong bolt into the wrong hole. So keep that in mind. There are several types of bolts that are very close between the two systems. Hardness and strength are identified by typically markings on the head of the bolt. And whether it's metric or SAE, either one can have the same distinction. The head of the bolt will tell you the strength of the bolt. This chart gives you an example. You can see that a no marking bolt would be considered a grade 2, 3 lines grade 5, and 6 lines grade 8. In a metric bolt, the higher the number, the stronger the bolt. There are 3 different ways to rate bolts: proof load, minimum yield strength, and minimum tensile strength. Each of these has certain characteristics that engineers use to measure what bolt they want to use for what application. I've put a website down at the bottom of this slide, and you can go to that website and get some very distinct definitions and very detailed definitions and characteristics of fasteners, much more so than what the book has. This is actually a bolt and nut manufacturer with a very good website and how to explain all the different characteristics of nuts and bolts. I'm going to publish this PowerPoint in Canvas for your reference. If you want to go back and check any of this information, you will be able to go back and get to this specific PowerPoint as a PowerPoint without the narration. Threaded fasteners. When we talk about threaded fasteners, one of the critical issues that we have to address is torque. Torque, if you remember, is a twisting or rotational force. When you go to a door and you twist the doorknob, you are applying torque because you're applying force in a rotational or twisting manner. Most fasteners on automobiles must be tightened to a specific correct amount. Not enough torque causes fasteners to loosen. Too much torque can lead to breakage. This is an example of 2 bolts. These bolts came from a school vehicle and show what happens to bolts that are over torqued. That's why it's critical to always check torque specs and ensure bolts or nuts are torqued to specification. I've tried to illustrate here the difference. If you look in here, you can see how this bolt is actually shallower. It stretched this bolt because it was over torqued. It's supposed to be that diameter, but here in the middle, the bolt has stretched and the diameter is lessened. If we go up to this bolt here, you can see how this bolt's even a smaller diameter in the center. This bolt was tightened even more to a point where it broke. So these bolts represent an example of what can happen when you over torque bolts. They can be stretched and they will be prone to breakage. When working on a vehicle, care must be taken to make sure you put the bolts back where they came from. The following pictures represents what happens when students mixed up a couple of bolts when assembling a brake caliper on a school vehicle. The picture on the right, you can see the difference in the height of the bolts. Not much difference. When they put the bolt into the car, they put the longer bolt where the shorter bolt should have gone, and this is actually the brake rotor of the car. The bolt was against the brake rotor and actually froze the wheel until we applied enough gas. It started to move, and it actually rubbed the bolt against the brake rotor enough to wear the brake rotor and the bolt. So it becomes very critical. A little difference in hardware can make a big difference in what happens after you service a vehicle. So you need to be careful and make sure that the right bolts go back exactly where you took them. This is one of the beginning technicians' biggest failures, is not paying attention to what came from where. Pitch gauges are basically like a sawtooth. They have several blades with teeth, and they are used to match the thread pitch on a bolt. US and metric pitch gauges have the same procedure, and it's just like using a saw blade to measure the teeth on a bolt, of the threads on a bolt, and figure out exactly what pitch they are. Some common non-threaded fasteners are pins, and we have typically got three different types. We have a straight dowel pin, which is a solid. We have a taper pin, which is tapered and uses a taper to compress and lock it in place. And then we have a roll pin or expansion pin, which is actually hollow and split. The purpose of a roll pin is once you drive it into a hole, you compress it, and the tension of the pin expanding out helps to hold it in place. Snap rings are often used to hold parts on a shaft or into a part. Snap rings can be internal or external. They require special pliers to remove or install them. Keys or cotter keys are a way that we can lock a pulley on a shaft. There's actually a cut in the shaft. The key fits into that, protrudes above the shaft. Then there's a keyway in the pulley that lines up with the key, and that's what we use to turn the pulley. Many cars use that on a crankshaft and pulley as the main drive pulley. We also have splines. This is typically an application shown here where we have a slip yoke on a transmission output shaft. You'll notice the length of the splines means that we have got some movement back and forth. This helps accommodate drive shaft angles and drive shaft length changes. So the splines mate and they can slide back and forth to accommodate changes in length. Rivets are a common part that are used in cars today. They hold parts together that are very seldom disassembled. Window regulators, door window motors can often be used with rivets. They are put in as a permanent installation and not made to be removed. They typically have to be drilled or chiseled. When replacing a rivet, replace it with a like rivet. Do not use steel where aluminum is removed or vice versa. Make sure, again, you use the same type rivet to replace what you've removed. So in summary, most common measurements in the United States is the USCS, although the vast majority of cars made in the past 30 years are built to metric measurements. The USCS system is based in the inch. The metric system is based on the meter. We are in a world market, so even though cars sold in the United States may seem to use the USCS system, all vehicles manufactured in the past 30 years are manufactured to metric numbers. Using the right tool for the right job, again, is important. We always have to make sure that we torque fasteners. They cannot be over-torqued or under-torqued. Many automotive parts are also held together with non-threaded fasteners.